Okay, so it's time to get started, and we're first going to look at Pythagoras' theorem. This is a theorem that you'll have seen before and used before, so this should be revision, but just making sure that you picked it up quite correctly. Pythagoras was quite an interesting guy. He lived on the island of Samos and isn't just responsible for this particular theorem about how to find missing angles on a right triangle, but was also a great philosopher in his own right and the leader of sort of a cult, really, I think would be the word I'd used, which he called the Pythagoreans. So let's have a look at what a right-angled triangle. If you're American, you just tend to call it a right triangle. The key with this kind of triangle is that there is a right angle in one of the bottom corners. Doesn't even have to be the bottom. That right angle has two short sides and then a longer side, which is called the hypotenuse. Hypotenuse is a really funny word, but it's an old Greek word to mean to stretch. And if you have a look at that triangle, the hypotenuse is stretched between the two short sides. So let's actually have a look at the theorem. Theorem says this, that in a right-angled triangle, if A and B are the measures of the legs and C is the hypotenuse, then A squared plus B squared equals H squared. Depending on the textbook you use, you sometimes see that H squared can also be called C squared. That is quite normal. I tend to use H squared so that I remember that it's actually the hypotenuse we're talking about, not just any other side. All right, so here's a randomly wandering triangle in green who's missing its longest side. And we're going to be able to work out what that missing side H is without having to measure. And that's an important comment about Pythagoras' theorem because it allows us to find information without actually having to get a measuring tape out. The first thing I'm going to do is find the two short sides. So I note where the right angle triangle is, and I know that the two short sides will always be hugging it, so I label them A and B. It doesn't matter which is which. I also note that here is the hypotenuse, which is the long side, which is stretched. The next thing I'm going to do is write down the theorem. There are two reasons I write down the theorem like this. Number one is so that I have something that I can easily transpose the numbers into without making too many errors. And also, I'm using somebody else's theorem. So unlike in English where we have to cite anything, one of the things we like to do in mathematics is actually just simply write the formula down rather than using. It's kind of honoring whoever came up with it. So here is Pythagoras' theorem. I'm now going to insert any numbers that I know into that theorem. I know from this diagram that A is 12 centimeters. I'm not going to worry about the centimeters, I'm just going to use the 12. So there we go, I've got 12 and I'm going to square it like in the theorem. The B side here I know is 16 centimeters. So I'm going to insert the 16 and square it, and I know that that is the hypotenuse squared. The next step involves using my calculator. Remember my best friend? This one looks a little different, I think, to the one you use at school. Don't panic, this is just my Casio at-home calculator. I'm going to simply input 12 squared, and I'm going to add 16 squared to it and press equals. This tells me that H squared is equal to 400. Now, I do not need to write this step down on the paper or on my working unless I want to. I've put it here just simply so you can have a check. The last step is to get back to the side, because you may have noticed that on the diagram that long side is called H, but I've actually worked out what H squared is. So to do that, I'm going to take the square root. Okay, so the square root of 400 on my calculator gives me the answer 20. So I know that H is 20. This is the bit where I need to remember to insert that unit again. If you have a look, both of the units were the same, they were centimeters, and I'm finding another length, so therefore the unit on here is going to be centimeters. Okay, so here's a second question which is identical to the previous one. So here I am formally going through my working just as I did. Notice I didn't need to have the diagram for this because I know the two shorts are 12 and 16. In this one I've actually worked out the numbers, but you don't need to do this at all. You can do that on the calculator. And there is my final answer of 20. Okay, so let's try a second problem here. I've got a triangle and I know that the two short sides are length of 6 and 12. There are 4 possible answers here and I'm going to try and find out the one which is correct. What I shouldn't do is guess, because part of the reason for doing this is actually to see if I can get my working correct. I like to draw diagrams, so that's what I'm going to do right now, and I encourage you to do that. As you know, I can't draw at all, but I can still get the information in front of me. So here is my right triangle. I know there are 2 sides and they're short, and this is 6, and I know that this is 12. In this problem, I haven't been given any units, so that's a bit of a pain, but I'm not going to worry about it. I am looking for this missing side here, which I know is the hypotenuse. I'm going to write down the formula that I know. So that's a squared plus b squared equals h squared. Or remember that you could have used c squared if you wanted to. I just tend to use h squared. I'm now going to make sure that the labels on my triangle match. Let's replace the numbers. I know that the number a is 6, so that is 6 squared. And I know the number b is 12, so that is 12 squared. So I've now filled in my formula. Time for my best friend, right? Okay, so I've got 6 and I'm squaring it, and I'm adding it to 12 and I'm squaring it, and I get the answer 180. I'm going to write that down on the screen. You don't need to do that. You can go straight to the next step. The important bits in this formula is this line and this line, okay? My last step is to remember to root both sides. So let's have a look. I'm going to root, and I'm going to root 180, and I'm going to get 13.4164076. Now I'm going to go back and have a look at the answers. The nearest one is this one here. It's been rounded, so 13.42. So that is the correct answer.